Our morning breakout, big climate data enabling 20 years of rainfall measurements to empower community resiliency with Emily Mercurio, CEO of CivicMapper. Emily, we are so glad you could be with us today on our final day of big data. The virtual stage is all yours.
Thank you so much. I'm going to share my screen now and get this going. Okay, so the popular question, can everyone see my screen?
Yes.
Awesome. Okay. Hi, everyone. I'm Emily Mercurio. I am the co-founder and CEO of CivicMapper. We are a Pittsburgh-based geospatial technology development company. And I'm going to be talking about a project that we've been working on for a few years, where we liberated 20 years of rainfall data of Allegheny County. And we developed an app to make it easy to access these data. And I'm going to show some examples of how this data can be used. So scrolling down here. So I'm just going to give you a brief overview before I launch into this. I'm going to talk a little bit about these data and like what they actually are. And then we'll talk about how we modernize this data pipeline to make the data more accessible and usable. And I'll go into a little bit about how we built the API to improve data access and visualization, and then show how it is usable for community resiliency with some local examples of storms in Pittsburgh that you may have heard about. And these images here are images that if you live in Pittsburgh, you're used to seeing. So we've got flooding in the bathtub area of the parkway as you head into downtown. And on the right here are people fishing during a sewer overflow. You can see sewage just pouring out into our rivers. So we'll talk a little bit about that. So this project was done with Three Rivers Wet Weather. They've been a longtime client of ours. And their responsibilities include, outreaching to municipalities in the Alcosan service area to help them cope with wet weather issues. So for the past 20 years, Three Rivers Wet Weather has been recording rainfall gauge data every 15 minutes within Allegheny County. And so that's, 4 measurements every hour. It comes out to 96 measurements per day at each individual rain gauge. And in addition, these rain gauge data are used to calibrate NextRad radar data to create a map of kind of interpolated on the ground rainfall estimates for every 1 square kilometer within Allegheny County. So this gridded map you see off to the right of the screen is showing what that 1 kilometer grid cell looks like. So basically it's taking the sensor data of rainfall. These are like tip bucket sensors, and it's interpolating between those cells to calibrate in much more higher accuracy what the rainfall is at each cell across the county. And this is a great resource because you're able to calculate rainfall across large geographic areas. So in addition to every 15 minutes at the sensor, you're also doing this every 15 minutes for each individual cell. So you can imagine this is a lot of information. And these data right now within our region are used by engineers, planners, municipalities to help understand how much rainfall they're dealing with in terms of how infrastructure is going to respond to handling all of this rain and stormwater. And for this particular use, because we're dealing with engineers and responses for infrastructure, the data are kind of organized by these sub watersheds. So you may have heard of the Nagley Run watershed or Gertie's Run. So that's how we're kind of framing access to the data, and I'll explain that more in future slides. And these data provide an understanding of climate and its impact on infrastructure. And as we all know, we're seeing record rainfall in the eastern US, particularly in cities in the eastern US where we have aging infrastructure. So it is a big problem, and we can only expect this problem to continue in future years. Okay, so here's what these little tip bucket sensors look like on the upper left of the screen. And so there are 33 of these rain gauges across Allegheny County, that Three Rivers Wet Weather is managing. And next to that, we've got like the next rad. So there are 2,276 of these, like we're calling them virtual rain gauges, and those are representative of those 1 kilometer grid cells across Allegheny County. So, you know, when you take 96 measurements per hour or per day times 33 rain gauges, you know, plus the 2,276 virtual rain gauges, and then multiply that by 20 years, you're getting at more than 1.5 billion individual observation records. So that's a lot of data. And right around in 2019, the client like realized like, you know, we have some technical debt with this data. It's not so easy to work with. So we realized like we needed to modernize the technology stack. And part of that modernization was creating new data pipelines so that are consuming all of these different sources, creating a database that's capable of storing 1.5 billion observations, and then creating a searchable user interface. And on the bottom of the screen here, you can see how like all these sensors and locations are kind of overlaid. So we've got like the 33 sensors across Allegheny County, and then like the 1 kilometer grid cell, like virtual sensors. Okay, so so in building this data pipeline, we had to build this replacement stack for over 1.5 billion data records, and you know, they're still coming every day. And there was a few caveats we needed to keep in mind, and one of those was we had to respect the existing workflows. So the users of these data were used to accessing it in a certain way, and we didn't want to make it like too different so that it would be you know, annoying for them to work with. We also wanted to make the data available using geospatial tools. So, you know, a map interface, map visualization. And we also wanted to create an up-to-date user experience that's like more in line with the way that technology is going in terms of accessing large data sets. So our approach was to first think about like how to store a lot of archival data first, and then determine how to get data on a recurring basis from the various sources. And on the left here, you'll see like, you know, kind of this logical diagram showing like our process. And we were, you know, using AWS S3 buckets to help us manage this. And some of the needs for the data pipeline was that, you know, obviously we needed to create both recurring and periodic pipelines for the real-time and historic data set. So that is built into the way that the pipeline was designed. It also needed to be event-driven from end to end. We also wanted to have an inline process for long-term storage of raw source data. And then the bonus was that we wanted the services to only run when they needed to run. And we ended up using a serverless AWS via Stackery, and it just like really handled orchestration of all the AWS resources that we needed very well. And it also saved on resources and costs for us, which was important to the client. So they didn't want, you know, they weren't able to throw a lot of resources at this, so we were able to do this very cost effectively. So now I want to talk a little bit about the app development. So we talked about the data pipeline. So now let's talk about the app. And so mainly the app is used to access and visualize the data. It's still in its beta form, so don't judge us like too harshly on it. And it's tentatively called like Make It Rain. And effectively, that's like what you're doing when you access the app. So you can go to the Three Rivers Weather website and check it out under calibrated radar rainfall data. It's right there on their site. You can read a little bit more about it. And basically what you get when you go to this beta version of the app is you see on the left side a map with a scale bar, and on the right side you see the query architecture, which is a when and a where. And the app is letting the users retrieve slices from tables within the database and expose them simply through this read-only REST API. And in development of this, like the spatial location was a secondary consideration. And that's because we know that these sensors aren't moving. So it's easy enough for us to just associate that sensor with an ID that has that XY location. And then the rainfall values are returned for locations at points in time, and the locations, like I said before, are represented by the IDs. So when you come to this, you enter in your time scale, Then you select either if you want to look at the rain gauge specifically or radar pixels, and this is for the real-time rainfall section of the app. And there's 3 different sections. You can look at just historical rain gauges or just calibrated rainfall. This example is the real-time rainfall. So you put in your information. You can choose if you want to see a 15-minute interval, hourly, daily, or total, and then you click enter and you get your results. So here's an example of, this was last week I ran this. So this was last week's rainfall in the Upper Ohio / Allegheny / Mon River. So this is mostly like downtown Pittsburgh. And you can see we didn't get too much rain last week, maybe between 1 and 1.5 inches for the week. This is the cumulative representation. And in addition to having this like visual map output, which is tiltable, you can kind of press both mouse buttons and like fly around and zoom around and move it around. You can also get tabular output and export it as a CSV, which is great if you want to incorporate it into some other analyses that you're doing. So we talked a little bit about community resiliency, and basically like these tools are telling us how much rain and where the rain was. And so these rainfall data really help us understand the impact of climate on infrastructure and the built environment. And in addition, these data can help us improve understanding of flooding in general in our region. They can help us address and predict the volume of combined sewer and stormwater outfalls into our waterways, which is a huge source of pollution in our rivers. It also can help us estimate how much stormwater we need to take out of the sewer system using green and gray infrastructure. It can be used as part of the planning process. We can also put this API on other platforms and use it with machine learning protocols to better predict downstream flooding locations and volumes. So now that the data are kind of like at our fingertips, you can imagine the kind of possibilities that open up to bring this into other, machine learning and AI types of systems. And, there are opportunities for innovation with this data. They can be used in navigation and routing, to do some machine learning and teach like how to avoid these areas when it's raining this amount at this location. We can use information from reported floods and connect that back to the rainfall, where it was, how much it was, and come out on the other side with some intelligence about climate in our region and how it is affecting people. So one of the first case studies I'm going to show, this is an event that happened in 2011 on August 19th. And if you were living in Pittsburgh at the time, I'm certain you've heard of this. This was a flash flood event that happened in Nagley Run. It caused 9 feet of floodwaters to pool on Washington Boulevard in Pittsburgh during kind of like peak rush hour. And it killed 4 people, including 2 children. On the bottom of the screen here, you can see this rain event. So on the left, we're seeing this was like a flash storm causing a flash flood kind of at the bottom of this hill. So 14 cumulative inches fell within 15 minutes inside of this sub-watershed, the Nagley Run sub-watershed. And on the right, we're seeing a visualization of those data here. And right here is where that event happened. So, the floodwaters were like, 9 feet above, and the cars got stuck and people got, kind of like sucked out of their cars. But like, this is the point. And by knowing the extent, the volume and the rate of rainfall and accessing that data through this app in real time, and along with, having set elevation derived flow models, this is what is helping us identify and hopefully restrict travel in these flood-prone areas. And data from these storms can guide the development of better stormwater infrastructure at these known problem locations. So really, it's connecting the rain event to the flooding event is where we can, gain some extremely valuable insights that are not only going to like protect people's lives, but also property. as in the case of Hurricane Ivan. So in 2004, September 17th, Hurricane Ivan dumped more than 7 inches of rain in Pittsburgh in a really short interval of time. And one of the hardest hit areas was Millvale. You know, Millvale here in Pittsburgh is known for having flooding problems. It flooded to 7 feet in some places, and about 25% of the community there needed help from first responders due to the flooding and property damage. So, you know, we can take a look at this, the real-time calibrated rainfall data to help show, like, you know, what was actually happening here. It was a ton of rain across the entire Gertie's Run watershed. And you can see the picture here at the lower right. I mean, this is what it was looking like in Millvale on that day. And on the left here is another example of like the peak storm. You can really see it in the climate data that we were able to pull out from these 1.5 billion records. And as a side note, I don't know if it's coming through here. So the past few years, we've been seeing this kind of record rainfall in our region. You know, 2018, 2019 were some of the top 2 wettest years in Pittsburgh's record in history. So let's see, it looks like I'm a little bit frozen here. I'm not sure why, but this is actually at the end of my slideshow, so I can take some questions. Oh yeah, here's the chart that just came up. So wettest years on record, it was 2018 was number 1, 2019 was number 3, and then the year that we had Hurricane Ivan was number 2. And we can expect to see this in the future due to our changing climate. So yeah, so I will take some questions now, and just some contact information. If you want to learn more about this or you know, see some more examples, you can contact us at info@civicmapper.com. And we will be launching a new website this spring at civicmapper.com, and then we're on Facebook at CivicMapper. So yeah, I'm happy to take any questions you might have.
Emily, thank you so much. Now, we did have your colleague Christian is in the chat. He has been rocking it and answering questions. So I don't know if you want to address those, just give everyone else some more visibility and maybe expound on those a little. It's up to you. But while we wait for other questions to come in, that could be an option for us.
Okay, great. Oh, thank you, Christian. I'm just taking a look here.
And Christian, I'm going to ask you to unmute just so you can speak if you would like to. You've been...
Sure, yep. Can you hear me all right?
Of course, yes.
Oh, okay. A little background noise where I'm at. There was one thing I wanted to add to the first question about the comparison of satellite data with on-the-ground observations. So the derivation of the on-the-ground estimates is done by a company called View Associates. In their process, they actually produce a report of the differentials they're seeing between gauges and the radar estimates, and how they have essentially turned the knobs to interpolate on-the-ground rainfall correctly. That's part of just part of their process, and those reports are actually something too that eventually will be available on that website, so you can see the mechanics of the process end to end.
Okay, so
yeah, and one of the other things I wanted to mention is, like, you know, the app that we showed is in this beta version, but like, you know, future improvements to that will include like being able to see a chart readout on some of those rain events. So yeah, we're continuing to improve this for our client. And the way that it's shown, I mean, you know, we're showing the data by sub-watershed, but, you know, in theory, you could show much larger areas or custom areas. It's just that, you know, that's not what our client was asking of us, but, you know, the architecture is there to make that possible.
I'll add that a lot of our end users are engineers who are producing reports on behalf of municipalities to comply with DEP and EPA requirements. And so their use case is often, I just need one sensor or two, and I need a table, which is why basically we give them a way to download the CSVs. That's one end of the spectrum. On the other end, we have folks wanting to research, you know, look at all 20 years of data, look at patterns in rainfall, and correlate those with flooding events, as Emily was describing, and land use, and see what they can see.
Thank you.
Oh, here's a great question from Ashley. So due to the highly variant topography in Pittsburgh that would affect the flow of precipitation, do you see any issues with the granularity of our cells or the NexRad? So So I don't think we would, but Christian can jump in. But this is why we need to use detailed 3D topographic models, digital elevation models, in conjunction with this rainfall, so that we can calculate peak flow at any point within the watershed. Knowing what we know about how much rain is coming through. So, like, by itself, you're getting a certain volume, but it's much more effective to also consider the elevation data sets that we have that are in very high detail, to go along with that, to teach us like how much flow we can expect to come through any point, and especially at culverts and curb inlets.
And I'll add to that to say that Alcosan, who sponsors Three Rivers Wet Weather, is looking at densifying the gauge network, which would let us increase the resolution of the radar pixels. But the topography, as Emily said, is key actually in that kind of analysis, and the land cover data as well.
Right.
Also, the temporal interval. Right now we're at 15 minutes, and most engineers want 5. And that just lets them see kind of the pulsing of some of these storm events and understand that a little better.
Mm-hmm.
Wonderful. Thank you both for your great answers to these questions. Ashley, thank you for posing that question. I'm not seeing any more, and we are almost at the end of our session this morning. So I will say, unless another question comes in, thank you everyone for attending this morning's sessions with Google and CivicMapper. Don't forget from 11 to 12 to head over to the Last Chance Technology Showcase to take some time to chat with our event sponsors and hear some presentations from a few. DQ Communications in there presenting on SD-WAN for your business. Other sponsors would love to connect with you this morning. And we also have some time for you to meet in the networking room. And join us at noon today for Business as Usual for our keynote speaker, Peter Angeline from the Hershey Company. And you know what? I did see one more question come in, so let's take that.
Yeah, so radar sweeps at 6 minute, how do you get a 5-minute interval? I'm not sure, because we are using 15-minute. I don't know if Christian's got anything to add.
So the company I mentioned, View, who does the interpolation, we actually can get 5-minute data from them, and it's really just a matter of us creating that other data pipeline to get it. So it is. I'm not sure, actually, if that's the consideration. The gauges that can be really at any granularity because they register when they tip, which is when water falls in them. So it might be a balance between those two things for View. That's as much as I know on this end.
Wonderful. Well, thank you all again for being here. Great week of big data. Hope to see you all in person again next year for our next iteration in 2022 for Beyond Big Data. And enjoy the rest of your day. Again, don't forget to head over to the Tech Showcase and join us today for noon for Business as Usual at noon.
Thank you.
Thank you.